Hi, today we are going to talk about how to mathematically dilate a figure. So, to dilate a figure means that we are going to change the size of the shape, but it's going to remain the same shape, just maybe a little bit bigger or smaller. So, for example, let's say I have this shape right here, and I want to dilate by a scale factor of 3. That means I take each point in this shape and multiply it by 3. So my first point is 1, 1, and I just multiply it by 3, and so then that goes to 3, 3. And we'll call that A, and so it went to A prime, the new place that A is going to be. This next one will be called B, 3, 2. So B is 3, 2. And we multiply by 3 because we're dilating by a scale factor of 3. That means we're multiplying by 3. And it's going to go to B prime, which we just multiply by 3. 3 times 3 is 9, and 2 times 3 is 6. And then our last one will be C, which is coordinates 1, 3, 1, 3. And that when we multiply by 3, 1 times 3 is 3, and 3 times 3 is 9. So I now have a new set of points that I can plot to get my new shape. So point A is going to be 3, 3. So 3, 3. There is A prime. B is 9, 6. So 3, 6, 9, 3, 6. So 9, 6. Here's B prime. And I can connect these with a line. And then C prime is going to be 3, 9. 3, 6, 9. And there is C prime. And here is our new shape. That one was not really drawn well, but that's okay. Here's our new shape. That one's not any better. That has been dilated by a scale factor of 3. Now, some facts about this are that obviously the side lengths are different. So these two shapes are not congruent. They're not the exact same shape. But the angle measures are the same. So that means that the angle of A is the same measure as angle A prime. B is the same measure as B prime. C is the same as C prime. Because the angles are the same, everything was multiplied by the same number. This is just an enlarged version of the original. These two shapes are similar. So that is dilating by a scale factor bigger than 1. It's going to make the shape bigger. If I dilate by a small scale factor, by a decimal or a fraction, it's going to make everything smaller. So for example, if I started with this and I said, let's dilate by a scale factor of 1/2, well, instead of multiplying by 3 like I did over here, I would multiply everything by 1/2. So I'd end up with like 1/2, 1/2, and 1.5, 1, and let's see, 1/2, 1.5. And so my new triangle would end up a tiny, tiny little thing. Let's see if I can erase this. And it end up a tiny little thing over here. So 1/2, 1/2, and 1.5, 1 right here, and 1/2, 1.5. So if I multiply by a scale factor of 1/2, it ends up as a tiny little thing here where that's A, we could call it double prime because that's a different one, B double prime because it's a different one, and C double prime. So see how when we multiplied by a scale factor smaller than 1, so a fraction or decimal, then it became smaller. So that is dilating a figure.